How you doing, guys? We're doing the BARKER past paper that we've been doing. It's an Extension 1 Semester 1 paper from 2012. And this one is to do with the inverse tangent function. And of all the inverse tangents, of all the inverse functions, inverse tan gets picked on the most. So the question is, we've got given this function, f of x equals 3 times the inverse tan of x. The second part of it is we're going to graph it, and then we're going to find the range of it. So I'm going to do it that way because I'm going to graph it, and then after we've graphed it, it'll be easy to find what its range is rather than its range and then working out the graph. I just think that's an odd way of going about it, this way that they want us to do it. So we're going to do part 2 first. So what we're going to do is we're just going to start really basic, and we're just going to draw the graph of tan of x. So you can do this in your calculator. You just put tan of 0 into your calculator. You're going to get at this point. You put tan of pi in, you get 0. You put tan of minus pi in, you get a 0 point there. And hopefully you've seen, because when you type in tan of 90, which is tan of pi and 2, you're going to get undefined. You're going to get a math error on your calculator. It's because these asymptotes happen here. Beautiful. So hopefully you've seen the graph of y equals tan of x before. And if not, you can just plot points and kind of get something that looks like very similar to this. Now, what we're going to do is we're going to take the inverse tan of this function to draw the graph of y equals inverse tan of x. Beautiful. So don't mind what's in this blue box just yet. So when you're doing graphs of inverse tans of things, or no, not inverse tans, just inverse functions at all, the main point is you've got to swap your x's with y's. Beautiful. So what that means is, say we've got this point here on the normal tan of x function at pi 0. So this green point just here, pi 0. Then what you do is you just swap your x's with your y's. So instead of pi 0, you get 0 pi. So we go to 0 and put that point there in. Beautiful. So that's where that point came from. Say, well, 0, 0, when you flip that around, you get 0, 0 again. This point here, we had minus pi 0, and then when we flip that around, we're going to get 0 minus pi. Beautiful. So then we put minus pi in here, so we get 0 minus pi. So that's where these 3 points came from. And then you can see, say we put in 89 degrees just here, so that's just short of 90. We're going to get infinity. So I'm going to say, so at infinity, we're going to get like something close to 89 degrees. So what we've done here, we've just drawn this y equals tan of x, and then we've just swapped all the x's and y coordinates around, and then we've got this graph here. But this graph here, this green curves, they're not actually a function, because this graph isn't a function because it doesn't pass something called the vertical line test. And what I mean by that is, the vertical line test, say you've got this curve here, and something goes like that. Then it's a function. This green one is a function. If every vertical line you draw, it only passes through the curve once. But however, obviously, as you can see, when we draw a vertical, that's not vertical, but I'll do a better vertical line, it's going to cut it more than once. So what we've got to do is we've got to change things so we can pass this vertical line test. So if we just have, so this is just your y equals tan of x. Y equals tan of x. Just up above here, and we restrict the domain. So we had minus pi and 2 to pi and 2, and we just do that there again. So we're restricting the domain. So minus pi on 2 is less than or equal to x, which is less than or equal to pi on 2. Beautiful. Then when we do the inverse, we only get one of these things. We only get this middle curve here instead of all these ones. And when we put this through the vertical line test, put it through, and it only hits once. Beautiful. So this graph here is a function. Beautiful. So when it says sketch the range of the function, we need it to be a function. So we need to restrict its domain so that we can pass this vertical line test. Beautiful. So this is the graph of the function y equals inverse tan of x. So logically, when we times everything by 3, like we've got down here, y equals the y equals 3 times the inverse tan of x. every y value just gets times by 3. So it was initially 0 here, this y value, so we're timesing it by 3, we get 0. So that's where that one was. I mean, at x equals infinity, we used to have pi on 2 here, or very, very close to pi on 2, so we're going to times that by 3, and we're going to get 3 pi on 2, and so on. So this is the graph of y equals the inverse tan, y equals 3 times the inverse tan of x. And you can see right off this graph, so this is actually the answer to the second question, which just said sketch the graph of 3 times inverse tan of x. But obviously we can just read off this graph that, of course, the domain, not the domain, the range, sorry, which is what possible y values are there, it lies between minus 3 pi on 2 and 3 pi on 2. So the answer to 1 is minus 3 pi on 2 is less than y, which is less than 3 pi on 2. Beautiful. So that's the range and the answer to the first part. Beautiful. So what we've done is we've stated the range of the function. So that's 1 mark in the bag. And then we've also just sketched the graph. So that was 2 marks in the bag. Beautiful. So now we've got that function, and it's something that looks like that kind of, that, or maybe something like that. Oh, that was a horrible graph. Don't worry about that. Anyway, find the gradient. So when you think gradient, we're thinking first derivative to the tangent of the curve at x equals 1 on root 3. Beautiful. So let me just write that down here. So at x equals 1 on root 3, we want to know the gradient. Okay. So of course, hopefully you've done a bit of differential calculus, and what we can do is we're going to differentiate this function to find the first derivative. So I've just put in a box here the rule that we're going to use. So if you've got y equals inverse tan of x, then the first derivative of that will be 1 over 1 plus x squared. So you could probably find that in the back of your book, in the table of standard integrals. Or hopefully you've just memorized it by now. But if you haven't, just have a look at this. It's a pretty simple one to remember. So yeah, just try and commit that one to memory. So f dashed of x, which is the first derivative here, which is the same thing as dy dx, equals. So the 3 stays the same because it's just a constant. And you can just differentiate and pull it out the front. And then the derivative of inverse tan of x is 1 over 1 plus x squared. Beautiful. How good is that? So I'll just quickly write f dashed of x equals 3 over 1 plus x squared. Now we want to know the gradient at this point here. So I'm going to write f. So the notation for that is you can say f dashed of 1 on root 3. And that's really a very short way of saying, very powerful way to communicate, because you could have written, you know, when x equals 1 on root 3, you know, the gradient equals, and then, you know, sub things in. But this is just a much easier, simpler way of doing things. Beautiful. So there's a 3 on the top, and then we're just going to put in 1 on root 3 into here. So 1 plus... So we're going to square 1 on root 3. So that, of course, is just going to be 3, because when we square 1 on root 3, we just get 1, and then this just becomes 3 on the bottom. Beautiful. So that will equal 3 over, then we're going to get 3 on 3 plus 1 on 3. Beautiful. So that's 3 over, now what have we got here? We've got 4 on 3. And we're dividing by a fraction. So dividing by a fraction, easy as pie. Flip the second and multiply. Yep, so that's someone who had probably psychiatric issues in year 7 told me that. So 3, so what we're going to do is we're just going to flip the bottom and multiply. Beautiful. So hopefully you've seen that before. You just invert it, and when you're dividing by a fraction, you multiply by what the inverse is. Beautiful. So that will be, so instead of x here, we should have 1 on root 3. Sorry. And that's going to be 9 on 4. Beautiful. So that's the gradient at x equals 1 on root 3. So you can tell when x equals 1 on root 3, so this is 1 on root 3. The gradient here will be, the gradient of this tangent just here will be, what was it? 9 on 4. Beautiful. Alright guys, well I've just gone under 10 minutes. Beautiful. I want to go watch Django Unchained. Have a good night, and I'll see you in the next one.